My name is Mohamed Usman Mohamed Rizan. My registration number is 2537575. Today, I am here to present my banana API project. I will first show you a quick demo, then explain how the code demonstrates version control, event-driven programming, and virtual identity. You can register using your email, entering the password, and when successfully created, you can see that MongoDB database it is being created, and I have used bgrid layers to encrypt the password. Let's start the game. Um, Time is showing. Control score. And you can see in the leaderboard that is recorded and it is sorted according to the role per match. This is the demonstration. Now let us go to the code base. And this is the entry point of the front end. It creates the React app and runs it in browser router, which enables navigation, and toaster, which is used for notification. Let's go to the next folder. Uh, this file defines the route structure. Login, register are public routes, while the lobby, game flow, leaderboard are protected routes. This is how I keep the authenticated parts of the app separate from public pages. Now let us dive into virtual identity. This is the file manages virtual identity on the front end. When a user logs in or registers, the token and the user details are local, saved in local storage. On refresh, the app restores that state so the user stays authenticated. Logout clears the token and the user data. Logout clears. Let us move to the backend and look into auth controller. On the backend, authentication is handled here. The register and login functions validate inputs, check the password, and generate JWT token, which is with, with a 7-day expiry. The token is returned to the front end with the user details. This is the middleware reads the token from the authorization header, verifies it with jwt.verify, and attaches the decoded user to the request. That is what protects private routes and establishes user's virtual identity. Now let us dive into event-driven programming. This file shows the request-driven structure of the backend. Each route is triggered by an event from the front end, such as starting a game, saving a match, or loading stats. The leaderboard route is a public route, while the other routes require authentication. When a game session starts, the code increments the user's played games played. When a match is saved, it stores the match and updates the user's goals, and the leaderboard is generated dynamically by calculating goals per match and sorting players. This is event-driven programming because the application reacts to user actions and server requests rather than running in a fixed linear order. And in the front end, we had event-driven programming like starting a game and the timer. They were all event-driven programming. Now let us go into interoperability. This file connects my application to the external banana API. The fetch banana puzzle function requests puzzle data and fetch multiple puzzles. Users promise all to fetch several puzzles concurrently, that is interoperability between my frontend and third-party web services. This is the backend file, shows interoperability between the frontend and backend. It enables pause, mounts the auth and game routes. In the production, it serves the build create frontend from the backend server. That means the whole application works across different layers and still behaves as one system. As you can see, I have been using a modular structure, so version control is easy. I have used pages, libraries, context, and components in the front end, as well as in the backend. I have used modular structure so I can update the workspace. Thank you.